Anybody else need a stylus too? I've just got short, fat ones. So I'll need them back. Anybody else? All right. When you're learning or reviewing information, this is kind of just in general. It's really good as a study skill habit to work on first getting a connection to stuff you already know. As a teacher, that's how I usually try to begin my lessons, or as I'm teaching something, is try to connect it to something that you already know from another class. Because that's how your brain stores information, is it takes something that it already knows, and then anything new that you're learning, it's try and make connections. Otherwise, if it can't make a connection, it's probably not going to stick. So we're going to try to make some connections here first to things that you already know, and then hopefully the more we practice, the more it'll stick. All right, so parallel lines, because parallel lines are how transversals exist. Let's figure out what we know about parallel lines in general. So, anybody want to volunteer something about parallel lines that's true? They never cross. Is that what you're going to say, Alan? Okay. They never cross. Okay. The other word that we can use there is they never intersect. Anything else? What about slopes of parallel lines? They're the same. Good. Okay. How about in a figure, like if you have a geometry figure drawn, or lines that are drawn, how do they let you know that the lines are parallel? Like what has to be on there to make the lines parallel? Like if I just draw two lines like this, they kind of look parallel, but are you guaranteed they're parallel? Ah, good. If it has a little dash, like a little arrow, that's how you know that those are parallel. That's like little notation stuff that you would need to be looking for. So, notation. I'm just going to circle them. But those little arrow or marks would have to be there. Kind of like if you have a triangle to show that two sides are the same, like each of them would have a little tick mark over it. It's the shorthand way of saying these lines are parallel. Okay. What about shapes? Are there any shapes that have parallel lines in them? Squares, rectangles, parallelograms. Okay. So squares, rectangles, parallelograms. There's another shape called a rhombus. Does that sound familiar, rhombus? That has some parallel sides. Trapezoid. All these shapes have at least one set of parallel sides. Do you think that's important for those shapes, an important attribute? Yeah? I mean, in a lot of ways, if some of these shapes didn't have parallel sides, they wouldn't exist. Like, especially the parallelogram. I mean, the word parallel is in it. So. Okay. So parallel lines play an important role in many shapes, many real-life scenarios. What's a real-life scenario where it would be an issue if the lines weren't parallel? Architecture, buildings. I mean, if the lines aren't, not that all lines are parallel in a building, but probably some lines better be, otherwise your building's going to fall over. What about vehicles, some kind of transportation? Road, those don't necessarily have to be parallel, but something that travels on steel. Trains. Would it be an issue if the tracks weren't parallel? Probably. You'd have some derailed trains. That's why derailings happen sometimes, is because one of the tracks is a little bit off and the wheels catch it and just flips it. So those need to be parallel. They can turn, but as they turn, they still better be like with each other, the same slope. Okay, so those are the real life scenarios. Constructions, their properties are essential to know and relate to all different situations. So if you work in construction or architecture or anything like that, I mean, parallel lines are all over the place and are a super important part of the actual architecture of the building. Recognizing when parallel lines are in play tells you a lot more than you think about a problem. So some of the problems that we're going to look at, they don't look like this, and they won't have marks, but recognizing, hey, these two lines are going to be parallel, that tells you a lot more about the shape. All right, what we're focusing on today are transversals. How many of you have at least heard the word transversals? Hopefully everybody. Okay. Transversals are a key result of the properties of parallel lines, and that's what we're going to focus on today. So we're going to label some key terms and list corresponding properties underneath. Okay, let's make these two lines parallel to begin with by marking them. And then you're going to have to follow along with me here. I'll try to zoom in. I'm going to mark some of these angles with numbers so that we can actually identify them underneath. Okay. So the ones that are labeled with a 1, those have a name. You'll notice that they're kind of on opposite sides. One's above the top parallel line to the right. The other one's below the bottom parallel line to the left. Those are called alternate. Does anybody remember the second word? These angles are on the outside. So another way to say outside of the line or on the outside of the line is the word exterior. So these are alternate exterior angles. These are on the opposite side of this transversal, and maybe we need to mark that as a transversal because that's what that is. Transversal is just a line that cuts two parallel lines. Goes through both. Okay, so this angle 2 is on either side of the transversal, but now they're on the inside of the parallel line. So these two angles are called alternate interior angles. Okay. What about if I marked this angle 3 as well? So this angle represents, it matches up with 2, and then we're also going to match up these two angles. What are these angles called when they're right across from each other like that? Starts with a V. Close, because they're connected by a vertice. These are called vertical angles. So close. These are the 3 main types of angles, and they all have special properties related to each other. Mostly that alternate exterior angles are equal in measure, alternate interior angles are equal in measure, and vertical angles are equal in measure. So technically, you'll be able to find all those angle measures because we have 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 angles formed by that transversal. Given one of the angle measures, you would be able to find all 8. So that's going to be our first example here in a minute. All right, so corresponding properties underneath. Alternate interior angles. I'm going to use a geometry term here, are congruent. Meaning they're equal to each other. Alternate exterior angles are congruent. And then vertical angles are congruent. And probably should define what transversal is. Transversal is a line that cuts through parallel lines. Now we're going to practice some of this stuff. So, if you want to go ahead and flip when you're ready. Do you need a few more minutes here? Okay. And then I think we have 5 problems we're going to do together, maybe 4. Okay. The second one. Alternate exterior angles are congruent. The little tick marks just mean to repeat the word above. Yeah. All right. And flip. And just so you know too, I'll put the finished notes up there with the video. So if you do miss a day when we're doing whole group stuff, you'll have the completed notes that you can go through, plus you'll have the video you can watch, so you won't have to miss anything. All right, so we have 2 parallel lines here. I think you need to actually draw this. I don't think I drew it on yours. No. 2 parallel lines, a transversal, and I'm giving you one angle measure of 73 degrees. Now, for the sake of these notes, we'll be doing more than just writing degree measures in there. On the side, we'll probably identify how we got some of those values. Okay, when you are trying to find a value, so normally like on the ACT, it'll just say, find the value of x, and it might have, one angle measure like that, and then x would be one of these other 8 angles. And then based on the properties of transversals, you would have to figure out what that is. For practice sake, we're going to actually find all 8 here. Okay? So, let's start with the easiest one to find is, well, starting at the angle measure they give you. because this angle measure tells us these 4 angles right off the bat. The angle that's across from, so directly opposite, so here's one angle, the angle directly opposite, those are equal measure, those are vertical angles. So if this is 73 degrees, then this angle would also have to be 73 degrees. So we're going to mark that as 73 degrees. Now over here, I'm going to name this angle as angle AE. And I'm going to write the angle AE is 72 degrees because it's a vertical angle to the one that was given to me. Okay. And then what I do know about this line is that while this line is straight, it's not curved. So we haven't really talked about this yet. But if we look at just that top part, you have a straight line, and you have the angle AF and the angle FB that make up that line. How many degrees are in a line? 180. So if it gives you the angle degree of 73, how would I find this missing one? Subtract it from 180. So take 180 and subtract 73. What do you get there? What is it? 107. Okay. So we're going to say, okay, angle AF, that angle there, is 107. The reason being, we call that supplementary angles. So we didn't use alternate exterior, alternate interior. We used the fact that I know those add up to 180. You could use the same fact here. If you looked at this as my straight line, here's angle FB, angle BE. Those would also have to add up to 180, correct? So that would also have to be 107. But the other thing that you can say is, well, this angle, if it's 107, this angle over here was the vertical angle to that one. And I know vertical angles have to have the same measure. Okay, so angle BE is also 107. And I'm going to write that it's a vertical angle. That's what the VA means, vertical angle, to that one that we just found, angle AF. But also it adds up to 180, so you could do either. Okay, so we could have found all of that by just having those two lines crossing. We could have found all those. Where the transversal with the alternate exterior and all that comes into play is when you add a second parallel line. Now, 73. So I'm going to go back to the original one they gave me. That's angle FB. What angle is the alternate exterior angle? So opposite side of the transversal on the outside of the parallel line. What angle is the alternate exterior? C what? CE, right? Alternate exterior means opposite side of the transversal. So this is on the right side. My angle would have to be on the left side. And it has to be on the outside of that bottom parallel line. So the measure of this angle here also has to be 73 degrees because of that relationship that it's an alternate exterior angle. So we would say, okay, angle CE is 73 degrees because it's an alternate exterior angle. And then basically down here we're going to have a repeat of what we just did up here. Because this angle now, angle FD, that angle is a vertical angle to this one. So what's the measure of this one then? 73. Okay. And now if we looked at this as a straight line, this angle and this angle would have to add up to 180, so that has to be 107. And then what's this final angle measure? 107. Okay. You'll notice that inside, if we look at the four inside the parallel lines, your alternate interior angles are equal. And same thing there. So opposite sides of the transversal and inside, those are also equal. Okay, so we don't have to write down every single angle, because once you get one of them, you can find pretty much all of them using the same kind of properties. All right, let's look at example 2. We're going to find the value of x and y. Now, this is probably a more common problem, but it's definitely more than just basic understanding of transversals. But we're still going to use those properties. Notice, I didn't draw those very parallel, but those are my parallel lines. So this line is my transversal. I know those are parallel because they have those little tick marks on them to show that they're parallel. Okay, so this one's going to be a two-step process. I would start, well, I'll tell you this thing. There's two variables. When you have two variables, that means you're probably going to have to do two problems here, or at least use two setups or two equations to solve it. So two variables, two problems. Now, because I have this figure, and I can see that I have two parallel lines and transversal, I'm going to probably use some of these relationships we've talked about, like vertical angles, alternate exterior, blah, blah, blah. We're going to set up these two problems that way. I'm going to start with the one that pops out to me first, which is this relationship here. What are those angles called compared to each other? Yeah, they're vertical angles because they're directly across from each other. Okay, so vertical angles are equal. So I'm going to set them equal. Maybe I mark down here on my figure, hey, those are vertical angles. Okay. Now, this is a pretty simple algebra problem because I can pretty easily solve for x here by doing what?
Divide by 4.
Before I even divide by 4. Because I have this 3x on the right-hand side, what would I have to do there? Subtract. I want to get my x's together, so I'm going to subtract 3x, and I get x equals 1. That's 4 minus 3 would get me 1. Okay, so I have my x value, but I need my y. I can't just take this and plug it in for x here, because then, I don't have an equation, so I can't really get a value for y until I have an equation. So, that's when these alternate exterior and alternate interior angles come into play. If we look at this angle, and maybe it'll be better if I switch it this way, my little figure. I need something to either put here, so that I can set up my little vertical angle thing. But if I could find an expression to put here, then I could add those up and set them equal to 180, because I know those two angles would have to equal 180. This doesn't have an alternate interior angle to match up with. That's already written there. So I think this one's out of the picture because there's not anything to match up with it. But I do have something to match up here because these are alternate exterior angles. They're on the outside of the parallel lines and they're on opposite sides of the transversal. So if this is 4x, then this also has to be 4x degrees. Okay. So I'm going to say alternate exterior. And if you don't know that those two are equal to each other, you can't solve this problem. But they are alternate exterior angles. Okay, so then I'm going to come back to this relationship now that I've set up. I know that this expression, 4 times x plus y, plus this 4x would have to equal 180 degrees. So that's going to be my second setup here. 4x, that angle there, oops, not that you can see it, that angle there, plus that other angle, which is 4 times x plus y. What does that have to equal again? I've said it a couple times. It has to equal 180. Okay, and now we're just in simplify mode. So I'm going to distribute that 4 through, and I get 4x plus 4y equals 180 degrees. I have some like terms there that I can add together, so I have 8x plus 4y equals 180. Remember, the goal of this problem is to find the value of x and y. I already have my x value. How do I find my y value now that I've simplified down as much as I can? You could do that, but I'm still going to have two variables. Yeah. Yep. I already found out that x is equal to 1, right? So now I can use that any time in the problem. I've already found what x equals. Wherever you see an x now, you can put the number 1. So that's what we're going to do here. We're going to substitute 1 in for x, since that's what x is equal to. And then 8 times 1 is just 8, so 180 minus 8 gets you 172. And then to solve for y, I'd have to divide by 4, which gets me 43. Okay. The key with these is not to get overwhelmed because there's x and y's, but to notice, okay, I have two variables, that means I have two problems. How can I use those relationships to set up my two equations? So we use vertical angles, and then we use alternate exterior. And we'll practice those more. Okay. The last three, we're probably not going to get to today. We'll pick up where we left off on Wednesday. What I would like you to do is open up the practice sheet that you got. And for the last, 6 to 7 minutes, if you could work on doing the first